Question number 6. This question is of numerical solution of equation. The equation cot 1 over 2x is equal to 3x has one root in the interval 0 to pi denoted by alpha. The value of x from this equation, the root of the equation is denoted by alpha in the given interval 0 to pi. Show by calculation that alpha lies between 0.5 and 1. In this part A, sign change rule will be used. Sign change rule will be used. First of all, we will write this equation cot 1 over 2x is equal to 3x. We can make it a single function, so we can write this. Let the function is x, fx will be let the variable, since the variable is x, so we can say that the function fx will be cot 1 over 2x minus 3x. Now this is a single function of x. This is a linear. Actually, there are two functions, cot 1 over 2x and 3x. Cot 1 over 2x is trigonometric function and this is a linear function. We have merged these two functions as a single function, cot 1 over 2x minus 3x. Now we have to show that root from this equation lies between 0.5 and 1. So first we will set the calculator mode on radian. Now separately we are putting these two values 0.1, 0.5 and 1 here. We will check the sign. First we put a 0 point in place of x 0.5. So f 0.5 will be cot 1 over 2 into 0.5 minus 3 into 0.5. Setting the calculator mode on radian, we will get the value of f 0.5 will be. Now this is reciprocal cot 1 over 2. Cot x is the, since cot x is the reciprocal of tan x. So because there is not on the calculator there is a key of cot x, so we can convert it into tan x. So we can write it as 1 over tan 1 over 2 into 0.5. After calculation, this will we get the value of this is 3.9163 minus 1.5. After calculation, we get 2.42. That is clearly positive. 2.42 is positive. This shows that value of f 0.5 is positive. Similarly, we will find f1 from here, putting the value of x is 1. So f1 will be cot 1 over 2 into 1 minus 3 into 1 3. Again we will calculate cot 1 over 2, 1 over tan 1 over 2. We get this value minus 1.17, or clearly this value is negative. So uh, the given value satisfy the sign change rule because f0 is positive, f1 is negative. So this shows that root lies between. This shows that root Root mean alpha because in this question root is represented by alpha, so we can say that alpha lies between 0.5 and 1. The next part of this question is show that B part is show that if a sequence of positive values given by the iterative formula is given. If a sequence of positive values given by the iterative formula this converges, then it converges to A. Simply, uh, we have to show that this will take this formula will take the original form of the equation, that is cot 1 over 2x is equal to 3x. So simply we have to rearrange this equation to show the first question from where which we have to find the value of alpha. So simply we have to rearrange this uh, iterative formula. First of all, we remove the subscripts in the bottom of x. There are n or n plus 1. First, these are subscripts. First, we remove these subscripts, then we will arrange. We can write this formula by removing these n's. We get x is equal to 1 over 3 within bracket x plus 4 tan inverse 1 over 3x. Now rearranging, cross multiplying, 3 will be multiplied by x, so this becomes 3x is equal to x plus 4 tan inverse 1 over 3x. This x will be moved to left side, 3x minus x, that is 2x. So we can write 2x is equal to 4 tan inverse 1 over 3x, dividing each side by 2. We get x is equal to 2 tan inverse 1 over 3x. So tan x over 2 will be equal to tan 1 over 3x. So taking reciprocal, uh, uh, first of all, and first of all, we have to x is equal to 2 tan inverse 1 over 3x, x over 2 is equal to tan inverse 1 over 3x. So we can write tan inverse on the left hand side, it will become tan x over 2. So tan x over 2 is equal to 1 over 3x, taking reciprocal each side. Reciprocal of tan x over 2 is cot x over 2. The reciprocal of 1 over 3x is 3x. This is shown. This is the same equation as it is given in the start of the question. So we have shown. The next part of this question is part C. Use this iterative formula to calculate alpha correct to two decimal places. Give the result of each iteration to four decimal places. Now we have to find the approximated value of this alpha correct to two decimal places by using the iterative formula. Iterative formula is given, that is x n plus 1 is equal to 1 over 3 xn plus 4 tan inverse 1 over 3 xn. This is iterative formula. From this formula we will find different iterations. First iteration, starting iteration is not given, so we can assume the alpha lies between, since it is given that alpha lies between 0.1, 0.5 and 1, so we can take a suitable value between 0.5 and 1. Suitable value, we can say that the suitable value is the mean value of 0.5 and 1. Adding both and dividing by 2, we get the mean value. So we are taking the starting value as 0.5 plus 1 over 2, so we get 0.75. So we are taking the first iteration, uh, that is represented by x1, we are taking it 0.75. 0.575, clearly it lies between 0.5 and 1. So we are taking this x1, the starting iteration. Now we will find x2 from the iterative formula. To find x2, we will put n is equal to 1, then we can get here x2. To find x2, we will put n is equal to 1. This will become x2, and right on the right hand side we will put n, and this will become x1, or this will also become x1. So x2 will be, putting the value of x1, x2 will be 1 over 3 x1, putting the value of n is equal to 1 plus 4 tan inverse 1 over 3 x1, putting this value of x1 here, we get x2. x2 will be 1 over 3, 0.5 plus 4 tan inverse 1 over 3 into 0.75. We get this answer of this iteration x2. We have to give the iteration of the result of each iteration to four decimal places. So x2 will be, after calculating this, we get the answer of the iteration is 4 correct to four decimal places, 0.8076. Now in the same way we will find x3. To find x3, we will put this n is equal to 2 in the whole of this iterative formula. X3 will be 1 over 3, the value of x2. Here is n is equal to x2, the value of x2 we have already found. Putting the value of x2, 0.8076 plus 4 tan inverse 1 over 1 over 3 into 0.8076. After calculating this, we get the answer of the iteration correct to 4 decimal places, that is 0.7911. Now we will find x4, that is 1 over 3. The value of x3 is 0.9. Put in here 0.7911 plus 4 tan inverse 1 over 3 into 0.7911. After calculating this, we get the answer of the iteration is 0.7954. Next we will find x5, that is 1 over 3 0.7954 plus 4 tan inverse 1 over 3 into 0.7954. After calculating, the answer of this iteration is answer of this iteration is 0.7943. Next, just we cannot find the from these two iterations we cannot find the approximated root, that is alpha, because not converging. So we have to find the next iteration, that is x6, 1 over 3 0.7943 plus 4 tan inverse 1 over 3 into 0.7943. After calculating this iteration, we get the answer is 0.7945. Now clearly from the last two iterations, converging is occurred because 0.7943 correct to two decimal places is 0.79, and the last iteration is also correct to two decimal places, that is 0.79. So converging is taking place here. So final iteration is the answer. Correct to two decimal place, we can say that the final solution, final value of a approximated root is alpha is equal to, correct to two decimal places, 0.79.